Welcome to my talk about MLOps in practice. So our journey from batch to real-time inference at Get Your Guide. So today I will discuss how we evolve our machine learning system to rank the activities. So yeah, let's dive into the agenda. So first I will introduce myself and also the company and what we do in my team in particular. Then I will explain how we de-risked this migration from batch to real-time by breaking it down into multiple steps, which each of them added values and allow us to learn on the way. And finally, then I will explain the challenges that arose from this new architecture and the key design decision we took to overcome them. And finally, conclude and open for questions. The presentation is pretty short, so that will be keep like around 20-25 minutes. So I hope we get a lot of questions. I think it's always interesting. So let's start with the intro. So my name is Theo. I'm a data science manager at Get Your Guide. And let me give you first a snapshot of what we do at Get Your Guide as a context. So Get Your Guide is a marketplace for travel experiences, connecting customers or tourists to activity suppliers worldwide, thanks to our website and our app. And more particularly in my team, we are responsible for the ranking of the activities on the website and the app. So we have different type of pages with different designs and with different flavor of ranking. So as you can imagine, it's a key component of our website and the app, and it's one of the major, or probably the major data product in our company. So yeah, as you can imagine, when you try to change such critical pieces, it's a pretty sensitive topic for many people in the company. So let's dive into the migration and how we handle it. But I will share to help you understand where we were 2 years ago and explain the limitation and where we wanted to go, basically. So before 2 years ago, the team we were responsible for scoring every activities in our inventory by some daily batches. And the search team, so another team, was responsible to rank the activity depending on the score. So higher the score, higher you should put the activity. So simple to maintain, simple interface with the rest of the company for us. However, we relied on other teams when we wanted to do anything for like a new scoring, for example. And it was pretty hard for us to go into segmentation or personalizing the ranking, as we were not responsible for the logic of ranking the things. Conclusion, so we built our own system, which is responsible for the ranking in real time. Now we can control the ranking logic. We can use a score or a model or something in between. I will see in a minute. And the new service the new service we need now to maintain. Before we're just dumping some file somewhere and someone was reading it and all was fine. Now we have a service that needs to answer requests. So the original vision was to have a machine learning model doing live inference using customer signals, but it's not what we start building actually. So what we wanted to de-risk it by breaking it down in multiple steps. And let's go through the different steps. The first one is basically, yes, sorry. So the first steps of our migration was to migrate our ranking to the service. The service basically just doing a lookup where we still had the score, which were loaded in the service, and we just order by it on the score. So like first with that, we were able to prove the feasibility of having such a service, that we were able to hit our latency constraints, that we also were able to verify that we had the same result than what search team was doing before. And so that increased the speed of launching new experiments, as we did not need to have to talk with another team that need to add tickets to their sprints, which start in 1 week, and all these kind of things happen. And also what we learned was all the technical challenges around having a service with the scale that we had. Okay, So then what we did, we started segmenting our ranking depending on some user signals, like what type of platform you are in or the language you use on our website. So then we had different scores for every type of users, and we ended up having a significant improvement in our ranking, which also helped us reinforce our hypothesis that the ranking need to be contextualized and later on personalized. That was kind of the future of the ranking for the team. Then we start training a new ranking model. Then we have a model in real time. And what we did is actually we reused the segment scores that were created before as a feature. We could find the optimal segment combination based on the past data to figure out what's the best ranking. And so with that, we were able to stabilize the model in production with this new framework, which was a new thing to us, to basically rank every request instead of relying on scores or some kind of combination of score. And also we learned to operate a machine learning model in real time and being able to generate the data to train it. And then finally, when this was done, then we start improving the model. What we have here is starting adding more relevant features to the user, like, for example, the price of the activity, the reviews that are associated with this activity, etc. All this kind of user signal that are useful. And also doing some fine-tuning to the model. And this also, this time, led again to a significant improvement in our ranking. Okay. So with that, we have the operation. So operating, as you can imagine, operating such a service comes with its own set of challenges. So let's dive a bit into the key design decisions that we made to overcome them. So first, the challenges we had were the following. So the website needs the ranking in most of our pages and should always be available. So high availability necessary. No one likes slow websites. And so as part of that, we had strict latency constraints. So we had to answer in less than 100 milliseconds. And finally, we know that we wanted to keep the velocity of development high. So we had constant change from the MLOps engineer and the data scientist. The receipt sounds like a receipt for incidents or breaking down the service when you put everything together, but having a complex service where it's in constant change by people that have different area of expertise and with high constraint on latency. But we managed to keep the system up all the time and without any major incident while being able to launch experiments in days compared to months as we were 2 years ago. We overcome such challenges mainly due to the following key designs that I will dive into. Make sure we have a clear ownership between the different experts in our team. Then we used extensively end-to-end tests with real data. And finally, we automated all of our workflow in our CI. So now let's dive into each of them. The first one, we use MLflow, which is an open source software to manage the machine learning model lifecycle that helps us to clarify the interface between our data scientist and our MLOps engineer. So with MLflow, we have a clear interface where the data scientist can focus on the feature generation. They can define the pre- and post-processing steps and wrap everything into a scikit-learn model. And then we can train and store this model in MLflow. And that's where we have the boundary. And then on the other hand, we have the MLOps engineer that are responsible for loading this model. They need to provide the feature for the inference, so fetch them, and finally ensure that the health of the service is healthy along the time. And so basically by that, we unblock everyone in the team to work on his or her specialty and having a clear definition of who is responsible for what. In my company and in my team, but not only in other teams, in other data products, we struggle for a while to validate our machine learning pipeline. Indeed, the thing is that they are about the interaction that you have between the code and the data that is kind of hard to separate. So to validate our pipeline, we first trying to create some dummy data that you can validate, but we kind of moved away from it because of the following reason. First, it's kind of cumbersome to create a machine learning pipeline with many data sources, and usually data products have many data sources. And it's hard to maintain hard-coded value or data-generated values, as you change slightly logic, and now the expected value is not 1.1 but 1.2, but how the hell did I get to this point now? Why should I change this value now? Or is it a bug? This kind of thing happen. And finally, there's still a risk to be different from what we have in production. What can happen is like something in your production data changed. They start to transform a string to a datetime. So your test still pass because you still expect a string in your unit test, but then you launch it in production and suddenly it starts breaking. So and also the thing that makes it even more challenging in machine learning is that you have unstable boundaries, much more unstable boundaries in our data set compared to other teams, because we are constantly trying to add new features or data sources. You are experimenting every time you change basically how your data. So we concluded that we should try to use production data for testing, but it's not something that we can do at scale because it takes a long time. So what we did end up doing is doing some sampling to be able to run faster. And so for that we needed some tooling that I will talk about now. So we developed in Get Your Guide an open source data flow, a tool that help us to sample data to run end-to-end tests as part of our CI, a continuous integration tool. So you can check it out on PyPI. I will briefly explain the philosophy behind. That's the thing. The more interesting is like basically what you have to do in this is you specify the data sources that you want to sample. So you have the different sources that are here, and when you run the code, you want. When you run the code, you have some environment that you need to specify that will define here where if you want to use the true data sources, and then that means that you are in production, or if you want to do it just on the sample data, then you specify another like the environment to have another value, and then basically it will run on this sample data, so it will be much faster basically. And also, as part of the tool, we also created another way to be able to download the data locally, but the sample data, because otherwise we'll not have enough memory on our laptops. But with that, you can still able to develop locally with true fresh data, but samples. So the running code make this sample data non-deterministic, because every day you have new data and we get the latest data of the day basically. So we needed to tweak our approach around the assertion for testing. So what we end up doing is having something that we call health check. In other words, we have some expectation of the data set or model. For example, for the data set, you expect like you have to share booking activity or book activity to be in a certain range. You expect to have at least some bookings on desktop, on MWeb, on things like that. If you have no bookings on one day, it will be a big problem for us. So probably that's happening. It's that there is a problem in the data. Also, you can expect the model to have an accuracy above a certain threshold. So we build this health check to validate that our data and our model are reasonable before deploying them. So running this health check as part of the end-to-end testing in combination with sampling, with the data flow. So with that, we can run everything as part of the CI in a reasonable amount of time. Of course, we have some lax requirements for the data when it's sampled, so we cannot expect to be as precise. As it's sample data, you have more noise associated with it, whereas if you want to run on a full data set, you can expect much tighter constraint on, for example, if you want to compute a conversion rate or something like that, it can be much more precise in your constraints. And what help us is basically all of the example I gave is kind of some metrics that we can also send to Datadogs. So then we can have a dashboard that have an overview of our services in terms of data. And so when we have some alerts with some metrics, have some dangerous trends, then we can directly get alerted from Datadog. Okay. So we changed the steps in the following way to in our end-to-end data test. Basically, first we need to sample the data with production. Then we can generate our data set for training based on this sample production data. Then we can validate our data set to make sure that we have bookings or at least some bookings. Then we can train a model and validate that the model that is trained on the sample data is still working. Basically, is also healthy in the sense of accuracy or things like that. Okay, that's the last point, and we automate everything in our testing and deployment in our CI. So that we mean that first, what we will do is run the unit test, then we can run our end-to-end data test in Databricks. So basically, as part of the CI, we actually launch a job, which will do this end-to-end data test with sample data. At the end, we get a model that we can push to MLflow. This model that is pushed to MLflow will be with sample trained. This sample model model trained on sample data can be also used to run some integration tests as part of the CI. Then we can train, if this is working, then we can train a model, a real model, by launching another Databricks jobs, but this time where we do it on the full data set. And we push our model, and then finally we can start the deployment process. And here, so we use Argo, and as part of our deployment, we can also use we also have a canary step that makes sure we are not running into problems, in the sense that we have some quite latency constraints, and the best way to make sure we rely on that is, as part of this canary, we start sending traffic and we make sure it's not breaking suddenly. Okay. This is... and what we did actually here in this deployment is wrapping everything, the model and the rest of the code, inside our Docker to make sure that we can directly send it to Argo, which is actually the tool that we use globally, which make it much simpler for incident management or things like that. It's like any other service that we have in the company. And the last part that we have is also on Airflow. So we have an Airflow DAG that is able to generate daily the new data set that we get from the previous day, where we will also run it on the full data set, but then also run the health check on this full data set. And once it's done, we can trigger a training step, which will launch a model and deploy it as before. So automating everything with this remove the room for manual error, and also simplify the deployment, because I lost my notes. Okay, well, I will do it's annoying. Where is it? No? Okay, I will do so without. Okay, so let's go to the conclusion. So I show in this presentation how we incrementally upgraded our data product by rolling it step by steps. And I think we had three key design decisions to make it work. So first, we had explicit ownership thanks to MLflow, we use production data for testing, but with using sampled. And finally, we automated all the workflow of testing and putting into production, so that we don't really remove room for error and make it possible for everyone to launch a new version. And yeah, of course, this journey sounds simple, but it was also full of surprise, good and bad. So, for example, I think like it took us quite some iteration to understand how we could segment the different data together to get to a positive experiment, much longer than we thought initially. And also learning on the ranker, how to use the ranker when we change frameworks to use this ranker in real time was also kind of a steep learning curve. But yeah, that was the work of a team for multiple quarters, and yeah, especially some other team members like Jean, Shengting, Olivia, and Mihail that are in my team that did a lot of work. Okay, well that's it. We still have quite some time for questions. So yeah.
Thank you very much, Theodore. I pushed the button in, right? It makes things lovely. So, questions for Theodore. I have a mic. If you don't speak into the mic, we can't hear it on the recording. So, I will come to you, and then you can speak. So this chap over here looks keen. There you are. Press the button.
Hi, can you hear me? Yeah.
Yes.
Thank you for the talk. Very interesting. Can you expand a little bit about the service that does the inference itself? So you said you deploy it to Kubernetes, but what happens there? Like, does it get a pickle file or a Nonix file, and what kind of service is that?
Sorry, what do you mean by... So in Kubernetes, then it's kind of... We just need to specify Docker, and then we have an infrastructure team that is responsible of making sure this service is healthy. We need to have some health endpoints that our infrastructure team will ping regularly. So in this sense, on this infrastructure, we have a kind of contract with them and say, okay, you have to have the health endpoints, and if it's not healthy, they will kill it down and try to restart the pod and things like that. But then it's kind of outside of our control. Like, we are not responsible, we are not interacting with this. We just have this contract with them in a sense.
Yeah, okay, that makes sense. Thank you.
Yeah, okay.
Hi, thank you for that. My question is more to do with Airflow versus MLflow. I saw you generated the sample datasets using MLflow. Why did you choose to use Airflow then to trigger the actual dataset?
Yeah, good questions. So the simple reason, generating the data set on the sample data is relatively fast because it's on sample data, so it takes around 10, 15 minutes. Whereas if you want to do it on the full data set, it takes a few hours. So we cannot run this. We don't want to wait a few hours every time, like just like this, every time we deploy models. That's why we have this Airflow things that is running outside of our CI.
Thanks, Theodore. I have a question about the assertions you're making on the models that you trained on the sample data, because you said obviously the accuracy will be different. So what kind of decisions are you making at this point in time for the pipeline? Because I see that you're making in a different place a decision about rolling out to production because you're using a full data set which is generated by the Airflow.
Yeah. So maybe so you can have, so basically what we look at is like things like we have on our model, we can look at NDCG, map, and we can have some constraints. So we are not looking at, we won't deploy a model if it's like 0.1% less on the NDCG or map, which has kind of, some ranking metrics. You can think of accuracy for ranking. But what we care is like if it's below 0.5, where we know that in the previous months, it has been around 0.7 and 0.8. If it's 0.5, there is definitely something really wrong happening. And we don't want to deploy this model. So we have kind of still lax constraint. What we are afraid the most of is having some terrible mistake that we order the activity in the wrong order, like we put the worst one top or something like that. And that's what we want to avoid. So does that answer your questions? Yes. Perfect.
Lovely. One over here.
Yeah, just a question about your technology choices. Not to question them, just to understand, like for example, Databricks, as far as I know, you can schedule things. So why are you using Airflow in this case?
Yeah. Good question. So you can schedule things on Databricks. The thing is, you cannot really coordinate things on Databricks. So the new version recently have this kind of workflow where you can coordinate steps step by one. However, still, I think Airflow is more on the scheduled thing. And why do we have this this Airflow thing? Is basically to be able to build our data set, we need to make sure that all the data sources have been updated before we can start generating the data set and joining all the events together. And this is scheduled on, already on Airflow, and so we can have some sensors. We say, okay, every day you wait for the impression events, the clicks events, the booking events of the last day to be ready, and when it's done, then you can start creating the data set for the day. So most of our infrastructure around data pipeline is on Airflow, and that's why we are using it here. And I think still it's a better tool than what they have on Databricks. Or I mean, I have a very limited experience on the one on Databricks, and we're happy with the one that we have in Airflow.
Okay, good. And yeah, just I suppose it's the same for the deployment, right? So you can deploy stuff in Databricks as well, but in this case, you said most of your infrastructure is already in Kubernetes, right?
So you cannot really deploy things on Databricks to be customer facing. So you can have cluster on Databricks, but if you have live requests, how do you send them to Databricks? That's not really the use case of Databricks. They have something around MLflow serving, but it's not ready for like external use case. Like when we talked with them last time, like around 1 year ago, they say, yeah, you can use it for internal one, but like concerning load balance or anything like that, does not make sense. Whereas here, our ranking is basically as part of every time someone Get Your Guide, then there is a request that needs to come to our servers that will call the ranking service. And so that's why we are part of the rest of the production infrastructure where we have all our services that allow us to have the website running. So it makes sense to have there here with the rest, so that it's faster and also makes sense that all the things that make the website, that's part of the ranking model, the ranking service is part of the thing that makes the website. So it should live together in some way, which is decoupled from what we have in Databricks, which is mainly around data pipelines and analytics.
Cool, thank you very much.
One over here.
Thanks for your presentation. I was just curious if you could walk us through a bit what it used to look like when you were doing batch inferencing and what bits were different from what you have now, because I can see like a daily trigger and I'm thinking if it's in real time, how is it like very different from what you used to do with batch inferencing?
So I'm not sure what's the, like, you want more details about how was it before and how we do it now? I'm not so sure it's the exact question.
Yes, with the workflow, the slide, almost the last slide, I think. Yes, I was thinking, based on this CI and structure here, how did it used to look like with batch inferencing? Did you have anything like this, or what was the infrastructure like at that point?
So there was no inference. So basically, we had no service. So we didn't have anything, basically. We just had we had things in a repository. We spin up a Databricks job to create a file that was put in S3 buckets, and that's it. Like, we had an Airflow that was building a kind of predict training, like predict score steps that was loading, that was depending on the code that we had in a repository to define how we score them based on ML model and Spark model, and then we output it to S3 bucket. That's it.
Okay.
So there was no CI or just like to update to build the wheel to push it so that we can use the latest version, and yeah, that was nearly nothing. Sorry.
Okay.
Does that make sense?
Yes, it does. Thank you.
So I have two different questions. Firstly, what motivated the move from batch models to real-time models in the first place? And secondly, you mentioned that there was a lot of surprises during the move. Can you give some examples of the biggest challenges that you faced?
Okay. So first question first. Why did we move for live? So we had basically one scoring for every activity, which means that we were not able to personalize in any sense. We didn't think that was the end. Like, we could make it even smarter to have better score every time, but we didn't think like we could get better just by on every pages all the same activities were ranked in the same order. And so that's why we say we need to move to something where we need to have more context and have something more personalized. And this was not possible with the current architecture. And the only one that made sense was to go in real time. Because if you start building, like if you start to pre-compute everything and then to send it, then the logic to define which value you need is complex, and it need to be handed over to another team. That was not really an option, and it's quickly explode with a number of possibilities every time you have some context. So that's where real time makes sense. So the second one, like the biggest struggle, I think the biggest struggle was to get like positive impact. So when we test our models, what we do is we always we test it in using A/B tests. So we separate our traffic, like every visitor is separated based on a random assignment. Half of them receive the old model, the one that we had, the control, and the other one, the treatment. And then we measure how much better this new ranking is. And there was a lot of iteration of, okay, we believe this model will be better because it's more personalized because it depends on some scoring, but it didn't work. And then we have to go into analysis, understand what went wrong, go with another version. We had hard belief that we'll get positive this time, not, and then we iterate a lot. So that's what took a lot of time. I think that's the biggest struggle we had.
Cool, we'll take a last question. Or a second question.
Yeah, so my question would be about your experience with MLflow, because obviously you're storing the models there, and the question is about the integration of this model into a service. So how do you pull it from this registry? Do you have like a custom-made Docker image that you pull, or do you have some kind of automation to convert a model from MLflow to generate an image and publish it on the image registry?
So wait, I have Yeah, so actually for the production, something that I cannot hide, but so basically we use MLflow for the model to store the model, but for prediction, basically we go to Bento-ML, which is another tool that is more focused around serving and micro batching. And basically what we get the model from here, you can load it, and then once you have a model, you can say, okay, to Bento-ML, okay, save the model and create a Docker image, which is a web service around this model that you can serve, and it has like some nice feature with fast API. Sorry, not fast API, but it has some. You have the open API specification out of the box. You can also specify things around it, and we created a Docker image with this thanks to Bento-ML that define already by default this Docker image. So yeah, so we don't use it. We also consider using MLflow for building the Docker. They have some capabilities around that, but there is no way to modify things. So for example, if you want to have two models inside web service, it's not possible. Or if you want to change the way you do the logging, it was not possible when we looked into it. I'm not sure if it's still the case, but there was really limited capabilities around customizing the code. Okay?
Lovely. Thank you very much, Theodore. Another clap for our speaker, please. Lovely, so that concludes this morning's sessions. Lunch will now be served. There is lunch tables over here. There are lunch tables over this way. everyone's going to go there, try out this one. There's going to be far less people. We've got lightning talks when we come back. If you want to give a lightning talk, there might be space. I might be lying. I haven't seen the board in a while. It's by the organizer desk if you want to put one down. There's another lightning talk section tomorrow. If you do want to give a lightning talk, they're coming up. Otherwise, have a lovely lunch, and we'll see you all after the break. Thank you.
Okay. And I'm happy to talk with you, any of you, if you have
He's happy
any
to
questions.
talk with anyone.
Yeah.